Okay, so we have our graph scaled here. Oh, look, and he can move my face. Okay, so we have our graph scaled. We counted by 0.2s on the bottom, so 0.2, 0.4, 0.6, 0.8. You see the distance between each one, if you subtract the bigger one from the smaller one, is the same as the first box because we want 0.2 to be in the middle. So if we went from 0 up to the next, it would be 0.2. We go 0.2 again, that would be 0.4. Okay, I think you get my point. And no, too, you can pinch and make this bigger. Hopefully it's not too small on your screen. Similarly, we also looked at, was going to stay in the Cami. We looked at what to graph, time and distance. For the test here, you're just going to, for this retake, you're just going to do, we just give you time and distance and you graph those. But anyways, so now we're going to put the data points on. Okay, so we scaled our graph. Now we're going to put the data points on. So this first data point, 0, 0, that's one data point. So two numbers, it's called an ordered pair, two numbers, 1 point on the graph. So that point would be right here. This is point 0 for time, 0 for distance, 0 for time, 0 for distance. Now we're going to go 0.2 for time and 2.0 for distance. So I'm going to go over to 0.25 for the time. Now I'm going to go up to 2 meters. So that dot data point represents 0.25 for the time, 2 meters for the distance. I'm going to do the next one, 0.5 and 4. So I go over 0.5 up to 4. Right there. Do the next one, 1 second up to 8. Right there. Next one, or last one, over to 2 seconds up to 16. So 2 seconds up to 16. And so I just put our data points on there. We also have to put a best fit line. Okay, so I like to use shapes. This looks like a linear pattern. I'm going to use a green line here. Green means go. Okay, like that. Okay, that's not the best fit line. You see here, because I got all my points below, so I need to fix it here a little bit. So it looks like this would be a better best fit. Now this should be a overall trends to your data. So if we want to make this a little bit fancier, we could have made them off by a little bit, but then we would have had to go over uncertainty, and that would be more complicated for everybody. And we're in distance learning, so let's try to make it as easy as possible. Okay, that's how to make a graph. In this next video, do we have time to go over this right here? Sure, let's just do it till I get booted. Okay, so does your graph show positive or negative velocity? Well, this line's going up, so that would be, yeah, I can tell you this, positive velocity. Does your graph show constant or changing velocity? The velocity here is constant. Constant. That would be constant velocity. Changing velocity would be like a curved line, like if the line like accelerated up or like slowed down. If the line was curved, that would be changing velocity. This is constant velocity. How far will the ball roll in 2.5 seconds? So if I go over to 2 seconds, it's off the graph, okay? But I could estimate, okay, 2.5 would be somewhere like out in here. So I could go up here, and if I extend out the line, okay, so I'm kind of like on the edge of my page. So 2.5 would be somewhere out here. So the graph, if we extend it up, looks like it would be about, it looks like about 20. Okay, so I would say that's about 20-ish. So that would be 20 meters approximately. And how much time will it take for the ball to roll 5 meters? Okay, so I just go over to 5 on the distance time. Okay, so here's 4, here's 6, so 5 somewhere in the middle. I go over to the graph, and it says, oh, that's about, let's call that 0.7. No, it's like 0.65. Okay, I'd say that's 0.65. And what are the units? 0.56 seconds, 0.65 seconds. Okay, so how much time will it take the ball to roll? 5 meters. Okay, so we went up to 5 meters over here on the y-axis. We went over the line. It's about 0.65. See ya. Good luck on your test.